Hello, hello, hello. Another day, another dollar. So, pause and copy. Let's talk. So, we're doing integrals involving lots of trig here. They get their own special section or two. What to do here? There are two possible ideas to begin with. I'm going to go u is cosine of x. We're going to see that works out quite nicely. So, standard substitution, blah, 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 work out dx, and move on. So, what happens? So pause and copy, and then I'll talk. I love to talk, talk, pause. Okay, so I perform my substitution. Cos squared becomes u squared. And dx becomes this. So I simplify, and I get to this step here. What can I do? Well, because, and this is the key, because this is an even power of sine, I can use a trig identity to write sine to the 4 in terms of u. Okay, so it's going to be 1 minus u squared, all squared. Okay, I repeat, it's because this is an even power of sine. Now, I think you can tell this is going to work out now. I've resolved my issue of mixed variables. The rest will be just expanding and sorting things out. So I expand. And then I integrate term by term. Oopsie daisy. Integrate term by term to get this. And then plug in u is equal to cosine. And that's pretty much it. So pause, copy, and now I will scroll back up and talk about u is equal to cosine. Okay, see how this power is odd and this power is even. Okay, so u is equal to cosine is the one that is going to work. What about u is equal to sine? Here's an exercise. Why don't you try doing u is equal to sine and see how it's not going to be pleasant. So I think this is worth trying, just to give you, you're building intuition here. Okay, so you want to do this work to get that money in the bank. Okay, next example. Here we have sine squared. Now, sine squared, cos squared, we're going to deal with these via trigonometric identities. So I have a memorized trig identity, which I just plug in here. And the point of this is that the power of 2, which is the difficulty, is no longer present in this circled expression here. So I can break that fraction into 2 fractions. And then integrate term by term. 2. Just let you copy that. Pause, copy. I'm going to say something very smart right now. To integrate this term, we end up with a 4 down here. Why is that? Well, because you have this 2 here, you're going to get an extra 2 appearing down here when you find your antiderivative. So you're going to have this 2 multiplied by this 2, giving you 4. And the rest is straightforward. Plug and chug.